Alaikum wa rahmatullah. Today our lecture about the blood group. So this lecture is very important because the blood group it's very important to understand the blood group. It be useful later on in your life. So the blood group and blood transfusion. What we mean when we say blood group? When we say blood groups, that mean we have many types of blood. And when we say groups, how we classify that blood group. So as we mentioned in the lecture of RBCs, I said we have some antigen on the surface of the RBCs. And we said the importance of that antigen for blood grouping and transfusion. Okay, so on the surface, just imagine it. On the surface of the RBCs, its rounded surface, we have antigen attached to that surface. Okay, antigen. What is that antigen? Okay, we have many types of that antigen. There is a large number of these antigen. Okay, the most important one is the ABO system and rhesus system. These are two important group of or system of that antigen. Okay, so I'm going to talk slowly because I need all of you to understand how we classify the blood group and it come from where, that antigen and that blood group. Okay, so we're going to start first about the ABO system. All of you know we have a blood types. We have B positive, A negative, A positive, B negative, O, A, B. Okay, all of you know your blood group. Okay, so the first system, the ABO system. We have two types of antigen in the ABO system, either A or B. Okay, and that two antigen it attached to the surface of the RBCs. So accordingly, we have four group of the blood. If the RBC surface contain A antigen, the person is blood group A. The group is determined according to the antigen. Okay, so if the antigen attached to the surface of RBCs is A, the blood group is A. If the antigen is B, the blood group is B. If the person have two antigen A and B attached to the surface of the RBCs, then the blood group of the person is AB. If the person have no antigen on the surface of the RBCs, then the blood group of the person is O. So A antigen, blood group A. B antigen, blood group B. AB antigen, blood group is AB. No antigen at all, the blood group is O. So those persons with the blood group O, they don't have antigen attached to the surface of the RBCs. Okay, I think it's very, very clear now. So this antigen are also found in the other tissue like salivary gland, kidney, liver, lung, pancreas, testes, and amniotic fluid, not just on the surface of the RBCs. So basically, all groups have H antigen. We have H antigen in individual with the blood group O, or the H antigen persists without conversion. In the person with the blood group A, their H antigen convert to the A, and in the person with the blood group B, their H antigen they convert to B antigen. So basically, we have one antigen called H antigen. Either that H antigen convert to the A antigen and the blood group become A, or it convert to the B antigen and the blood group become B, or it persists like this and the blood group become or it's convert to both A and B and the blood group become A and B blood group. So any person with the blood group, let's take it as first I need to take example. If me am blood group B, okay. If we take sample from blood group B person, we found antigen B on the surface of the RBCs, on the surface of the cell, and we found antibody A on the serum of that person. Okay, so any person with the blood group, they have antigen and anti-antigen. Okay, so the antibody, when we said antibody, that means antibody against antigen. Okay, so anti-A and anti-B antibody are acquired naturally after birth by unknown mechanism. Anyone after birth, they acquired antibody against either A or B according to the blood group. So any person in this world, they have antibody in their circulation against a specific antigen. Okay, why they acquired that antigen? We have a just theory how this antibody acquired. This theory said food contain antigen similar to the A and B antigen. Ingestion and absorption of this antigen induce the immune system to attack them by the antibody that circulate in the blood as anti-A and anti-B antibody. Okay, this theory said some food contains some antigen similar to that A and B antigen. Okay, ingestion of that food, if I ingest some food contain like antigen A, our immunity attacks that antigen A and produced antibody A. Okay, this is just theory, but basically any person after birth acquired antibody against A and B antigen. Okay, and another theory said certain intestinal bacteria contain antigen similar to A and B antigen. If these bacteria infect the neonate, the immune system will form the antibody against bacterial antigen. This antibody circulate as anti-A and anti-B antibody. Okay, this is the second theory. There is some bacteria, some intestinal bacteria contain antigen similar to A and B, and our immunity attacks that antigen A and B and produced antibody A and B. The most interesting fact is that the body forms antibody against the ABO antigen not present on the surface of the RBCs. For example, if someone is a blood group B, the body cannot produce antibody against that B antigen, no, because if the body produced antibody against that B antigen, the antibody will attack the RBCs. Okay, so anyone with the blood group B, they have antibody against A, which is it's not found on the RBCs in that person. Okay, so for example, a subject with the blood group A has antigen A on the RBC's membrane, so his body forms antibody against B antigen, anti-B antibody. Okay, accordingly we have 4 types of blood group. We have A blood group, B blood group, O blood group, and AB blood group. Those who have antigen A on the surface of RBCs, they have antibody B on their circulation. And those with the blood group B, they have B antigen on the surface of the RBCs, they have anti-A antibody on the circulation. And those with the blood group AB, they have AB antigen on the surface of the RBCs. They don't have antibody in their circulation, because if they have antibody either A or B on the circulation, it will attack the antigen on the surface of the RBCs and it will destruct that RBCs. Okay, and the fourth one, those with the blood group O, they don't have antigen on the surface of the RBCs and they have antibody to A and B on the circulation, because they don't have antigen on the surface of the RBCs. Okay, so those 4 types of blood group. Okay, A, anti-A antibody in subject with the B blood group, anti-B antibody in the subject with the blood group A, and anti-A and anti-B antibody in subject with the blood group O, and no antibody in subject with blood group AB. The ABO blood group are distributed as the following. The most abundant one is the blood group A, 42% of population, blood group B 8% of population, and AB only 3% of population, and blood group O is found in 47% of population. Sorry, that means that O blood group is the most abundant blood group. Okay, the most dominant blood group is the O blood group. So this is the first system, the ABO system. Second system is the rhesus system. Okay, the rhesus is, we have many antigens C, D, E, but the most common one is the antigen D. Unlike the ABO antigen, this protein are only found on the RBCs. It's not found in the other tissue, only in the RBCs. The most important of this antigen is antigen D. Accordingly, we have 2 types of rhesus, either rhesus positive and rhesus negative. When we said someone have a blood group of B positive or B negative, it's ABO and rhesus system. B is the ABO and negative and positive is the rhesus system. If someone have blood group B, that means he has antigen B, and positive, it means he has antigen D. So if someone have antigen D, we call it positive. If someone don't have that antigen, we call it negative. Okay, so what happened to antibody against that antigen D? Unlike the anti-A and anti-B antibody of the rhesus system are of the immunoglobulin G type, and that, as we know, the immunoglobulin G can cross the placenta. That antibody of ABO system, anti-A and anti-B, it's IgM. IgM cannot cross the placenta, but IgG can cross the placenta. Okay, so the antibody of the rhesus system is IgG. Also, unlike the anti-A and anti-B antibody, anti-D antibody cannot naturally acquired after birth. Okay, they develop only in rhesus negative subject, never in the rhesus positive subject. So we need to know how that antibody develop, because naturally, if someone has the antigen D and antibody D at the same times, that RBCs will be destroyed. The antibody against the antigen, it will attack it and result in destruction of the RBCs. So anyone with a positive blood group, they don't have anti-D. and also the negative, because as we mentioned, the antibody against the antigen, it's not naturally acquired. It just happen if someone receive blood from outside the body. Okay, we're going to mention how it happened. So the causes of their development in rhesus negative subject. First one is the blood transfusion of the rhesus positive blood to rhesus negative. For example, if someone have a rhesus negative subject, someone with blood group A negative, okay, and he received blood from positive patient, that means that blood contain positive antigen D, it enter to the person with negative blood, and the immunity sees that antigen as the foreign and produce antibody against that antigen. In this situation, the negative person, he have antibody against that D antigen because he received that antigen from outside through the blood transfusion. Okay, and the second situation is the delivery of rhesus positive baby with rhesus negative mother. Okay, as we know, during the labor and the cutting of the placental cord, there is some mix of the blood between the mother and the baby. So if the mother is negative and the baby is rhesus positive because the father is positive, okay, so that child with the positive antigen, some blood of that child enters the mother and the mother is negative. So the immunity of the mother sees that antigen as foreign antigen, and immediately it starts to produce antibody against that antigen. Okay, so now the mother is rhesus negative, but she has antibody against antigen D because of mixing of blood from the fetus. So it's not problem for the mother. But later on, if the same mother get pregnant again, okay, and as we mentioned, the antibody against antigen D, it's IgG, and IgG can cross placenta. Now the mother, in her circulation, she has antibody against D antigen. If she get pregnant with another child with positive blood group, she will transfer that IgG antibody to the fetus. And what happened? That antibody attack that rhesus positive fetus and it lead to hemolysis. Okay, so to avoid that situation, when negative mother delivered a positive child, they give her injection immediately to neutralize that antibody. I think all of you hear about it. Some of the mother need injection after delivery, okay, with the positive child if the mother is negative. Okay, so this how we get antibody against IgG. So as general, as we said, the rhesus either positive or negative. Okay, positive contain antigen D on the surface of the RBCs, negative no antigen D. There is no natural acquiring of antibody for that antigen D. Okay, how someone gets produce antibody against D in two situations: in the blood transfusion with the rhesus positive and in the delivery with the rhesus positive person. So the problem happen in those with rhesus negative. Okay, so the child of rhesus positive father and rhesus positive mother can be either rhesus positive or rhesus negative. A child with rhesus negative mother and rhesus positive father should be rhesus negative. Distribution of the rhesus in population. 99% of the rhesus of the population is rhesus positive, and only 1% is rhesus negative in Europe. In the other community, 85% is rhesus positive and only 15% is rhesus negative. That means the negative people, it's very rare. The blood group negative is rare. Thank you so much.